applies to any triangle, not just right triangle. And we are also going to find another formula to find the area of a triangle using some different information than before. So first of all, law of cosines is a bit more complicated than law of sines. The only two cases where you can use the law of cosines is if you know all three sides of the triangle, so that's the SSS we're looking at right here, or if you know two sides and the included angle. It's got to be the angle in between the two sides we know, so that's the SAS. So here's our law of cosines. The formula that I'm used to using actually kind of starts out looking like Pythagorean theorem. I'm familiar with the a squared equals b squared plus c squared minus 2bc times the cosine of a. So all I did from the formula you're given is square both sides. But of course, in order to solve for a, you would have to take the square root. So it kind of makes sense to use this first formula because you don't have any work to do after you substitute everything into the formula. So I like the second formula because it's a little easier to remember. If you're thinking Pythagorean theorem, the a squared equals b squared plus c squared, and then minus 2, because we have two sides that we're looking at, or that we know, bc, we multiply by those sides again, and then cosine of a. The big thing to remember with law of cosines, again, same as law of sines, is that angle A and side A are opposite one another. The order you substitute B and C in doesn't matter. So let's take a look at how this works. We're finding the length of side A in our first triangle. So we start with, and I'll probably write a squared more often than not, but we'll start with a equals the square root of b squared plus c squared minus 2 times b times c times the cosine of a. So we substitute into the formula, and then all we have to do at this point is evaluate. So I substitute all of that into my calculator all at once. Make sure that when you do that, you use parentheses around everything that you want your calculator to take the square root of. Most calculators automatically come up with a parenthesis for the cosine, and really it doesn't matter if you don't close the parenthesis as long as it's at the end of your list of things that you're typing in. So in this case, you don't need to close out any of your parentheses because you want everything under your radical sign. And I got about 4.950 for our side length. So let's take a look at how the law of cosines works for solving for a missing angle. The law of cosines that I gave you was solved for a side. So what I want to do is manipulate that formula to show you what it looks like when you solve for an angle. So I'm just going to use the a, b, and c because that's the formula I gave you. And I'm going to start with, I've already squared both sides, kind of that second version I gave you. All right. So most students make mistakes when they're solving this formula when the numbers are substituted in by forgetting order of operations, which is why I think it's helpful to have both formulas, one solved for the side and one solved for the angle. So the first thing I'm going to do is subtract b squared and c squared from both sides of the equation. Don't lose that negative sign in front of your 2. So in case you're confused as to what I'm doing here, since I haven't substituted any numbers in, I am solving the formula for law of cosines to solve for angle A so that we have one formula, generic formula for solving for a side, and one formula for solving for an angle. So at this point I'm going to divide everything by negative 2 BC. And then finally, to finish solving, I'm going to take the cosine inverse of both sides, and that's my formula down here. I wanted to show you where it came from before I just gave it to you. All right, so now we're going to take a look at solving for the measure of r. Again, what's most important is that we know which side is across from r, because that's what we're starting with. So when I'm substituting in for a, b, and c, it does not matter what you call b and c, but you need to know what a is. So I'm going to do measure of angle r equals 6 squared minus the other two sides squared all over negative 2 times each side. Sorry, and I'm really used to the formula where it's solved for the side. So I lost my cosine inverse. So we're going to take the cosine inverse of all of that. So when you're typing this in your calculator, again, what you need to make sure is that you have parentheses around your numerator so that the order of operations knows it needs to square and subtract everything before the division. And then I would just do one set of parentheses in the denominator and use, obviously, the times button for times. So we've got cosine inverse of, and actually, unless your calculator automatically pops up with the parentheses, mine doesn't. So I needed to actually type in two parentheses, one for the big grouping, and then the second one for just the numerator. So I got 6 squared minus 9 minus 49. And then I ended this parenthesis before I hit my division, divided by negative 42. And I got the measure of angle R is about 58.4 degrees. I think I mentioned this on the last video. Make sure any angles you round to the nearest tenth. Side lengths, I'd like you to keep 3 decimal places. All right, so here is this other formula for area of a triangle, and it's much more complex than the area formula we learned last night. So we've got S, looking at this formula here. This S is the perimeter of the triangle. So, now that I'm looking at that, times the 1/2, that's not the perimeter, but it represents part of the perimeter, half the perimeter of the triangle. So let's fix that, half the perimeter of the triangle, because we have this 1/2 here. The perimeter, of course, is A plus B plus C, so we're multiplying the perimeter by half and then substituting it into our triangle formula. And then A, B, and C are the 3 sides of the triangle. So we subtract the sides of the triangle from this 1/2. Half the perimeter. All right, so I've got the formula up again because it's a complicated one. So we're going to start with area equals the square root of, adding all of our sides together, we get 98, so half of that is 49. So our S is 49, and then we take 49 and subtract each of our sides. So 49 minus 28 times 49 minus 33 times 49 minus 37. Again, I just type this all in at once. And I got for my area about 444.486 square meters. Again, don't forget to label your answers. And last of all, applications of law of cosines, i.e. word problems. So I'm looking at this, and the surveyor is trying to figure out how long a lake is. So I'm going to draw my lake. Okay, so here's my lake, and he starts at one end of the lake, and he's probably going to approximate the end of the lake since it's not shaped perfectly, so I'm going to say he starts here and walks 245 yards. Well, obviously he's not walking into the lake, so let's say he heads off in this direction, 245 yards. He then turns 70 degrees and walks 270 yards until he arrives at the other end of the lake. So then this side will give us the length of the lake, so that's the variable that we're solving for. So this time we're solving for a side, so we're going to use that, I think it's the easier law of cosines formula. So we've got the x equals the square root of a squared, or sorry, that's the other two sides. Doesn't matter which order. The other two sides squared and added, we start like Pythagorean theorem. That's what threw me off, is I didn't start with x squared. Minus 2 times the two sides times the cosine of the angle opposite that side we're solving for. And the length of the lake is about 296.101 yards. And our last one, we've got this hurricane bending our poor tree. So to keep it from falling, they nailed a 6-foot strap, so here's the strap, into the ground 4 feet from the base of the tree. They attached the strap 3.5 feet above ground. So the question is, how far, this angle right here, how far was our tree leaning? So we know all 3 sides, so what we need to figure out is which side is our A. That would be the one across from the angle that we're solving for. So we start with 6 equals, this one is the angle one. So we're going to use our angle formula. So this one is theta equals cosine inverse of, we start with that 6 feet, so the 6 squared minus the other 2 sides squared, 4 squared minus 3.5 squared, all over -2 times 4 times 3.5. The 2 sides that are not across from the angle we're looking for. So the side across from the angle we're looking for, we use only once, and we use it first. And the other 2 sides we use twice, both numerator and denominator. Squared in the numerator, and then just multiplied by the -2 in the denominator. So we get 36 minus 16 divided by -8 times 3.5. And my theta is about 106.1 degrees. Now, depending on how you interpret this question, it says how far from the vertical was the tree leaning? This is the vertical, so we have to subtract 90 degrees from the angle we just found to figure out how far the hurricane pushed it. So it's leaning only about 16.1 degrees. All right, that is it. I hope you guys have a great weekend. I'll see you Monday.